Hello guys, welcome back to another lecture in this course, and we are going to look into logistic regression in our supervised learning algorithm. So logistic regression is a statistical models the probability of an event taking place by having the log odds for the event be a linear combination of one or more independent variable, and is actually used to examine the association of categorical or continuous independent variables. This procedure is quite similar with multiple linear regression. And if you have taken a look into one of my courses which has to do with data analysis, we have done a multiple linear regression. So here, instead of fitting a regression line, we are fitting an S-shaped logistic or logistic function, which predict two maximum values, 0 or 1. So the probability is either it's a 0, it's a yes or a no, it is wrong or it is right. So the curve from the logistic function indicates the likelihood of something either present or not, gaining weight or not gaining weight. So the bottom line is that this technique or this logistic regression supervised learning algorithm, it is used to solve classification problems. So we will be finding relationships between the two data factors. So logistic regression is used to calculate the probability of a binary event occurring. So if an event is going to happen, we use the logistic regression to determine either this event will happen or not. For example, predicting if an incoming email is a spam or not a spam, or predicting if the student will complete the online course or on time or not. So we are just checking the outcome of a probability, or calculating the probability of an outcome of anything using a binary method. So in this case, we are going to take a look by using iris data set. So here, if you are using iris dataset, first thing we need to import to load the iris dataset by importing the dataset from our scikit-learn .dataset. So if you run this line of code, we can actually see that we have our dataset here. This is our data, and we have our target. So now what we need to do now, from the linear module of scikit-learn, we need to import the logistic regression class. As you can see here, we have actually imported the logistic regression class from our linear model, where we have also imported our linear regression model in our linear model from our scikit-learn. After importing logistical regression, we need also to import the metrics. So this metric, what we need to do, the metrics, they will help us for checking model accuracy. Now let us create our logistic regression here. So we are storing it in our logistic regression model here by this. Now we create two variables, x and y, where x is our dependent, this one is our independent. This one is our dependent variable, then this one is the independent variable. So y is depending with the x. So we have x independent, y dependent variable, as you can see. And now, since we have already imported our train test split, so we are training our features, our independent and dependent variable here, and we are determining the test size. And on our test size, we can actually see that we want to train 70% of our data and test the 30% of our data. Then we start by shaping the data first here, as you can see. So we have shaped the data. Since our data is having 150 observations, okay, so on 150 observations, we have trained a shape here that we can see we have trained 70% of the data, which is 112, and the remaining 38, we can see that we have tested this data and we have reshaped this data, as you can see here. Now what we need to do is to make sure that it fits on our logistic regression model. So to fit on our logistic regression model, we are taking our X-train data and our Y-train data here, and we store the model here. So after storing the model, we need to see the prediction on the outcome. Okay, we need to see the prediction on the outcome, and the prediction we are checking on the accuracy, that is the result going to be a setosa or vesicular or vaginica. We need to see the result. So now we're saying the prediction is equals to model.predict x test. This test, the values that we have tested here. Then we are checking the accuracy of our logistic regression here by predicting our y test using the matrix that we have imported. So we run our line of code here. We can actually see that the accuracy of the logistic regression is 0.9736, which is approximately to 97.36 accuracy here. So we can actually say that this model of it is very accurate when you are classifying or checking the probability that is the data going to be vesinica, vaginica, is the data going to be setosa or vesicular or what. I think this is all for this lesson. Thank you for watching. See you on the next lesson. Bye bye.